Welcome to your presentation on history of manufacturing. What we're going to look at today is the need for manufacturing, history of manufacturing, key figures, and examples of the process. So let's take a look at why manufacturing. And I believe this is probably one of the first questions in your note sheet is the need for manufacturing, but it accounts for 12% of the U.S. gross domestic product and employs 9% of the U.S. workforce, which is about 1 out of 10. So it's a pretty significant part of our workforce. Manufacturing started out originally prior to the 19th century when things were made. It was always made by artisans, and artisans are just people skilled in a particular field. You can see this dude here is like chiseling some stuff out, and he's chiseling stuff with like a wooden thing here, and everything is handmade. Everything is slightly different right now. People start to pay a lot more for handmade things because everything is being mass produced. But things can be produced a lot quicker now with mass production and manufacturing. So artisans it's more of a hobby and a craft for at least much of the United States. Prior to the 19th century, Eli Whitney was really one of the innovators or initiators of the history or of manufacturing, and he was really most famous for this doohickey thingy here, which is the cotton gin, that's right. And but he went bankrupt because he was a bad businessman. So he left the South, he went to the North, and he took on the project of mass producing muskets, which led to the invention of the milling machine, which is right here. And many of you have watched a video about how Lego even used milling machines last year. So he quickly realized he had to break down this process of mass production into really, really small parts, and came up with the idea of interchangeable parts. So he'd make many of one type of piece, and then if that broke, then you could swap it out with something else. So one of his big ideas was interchangeable parts. Then we get on to the early 1900s, which is Henry Ford, and he revolutionized manufacturing with the introduction of the assembly line. You can see these people assembling. The idea was that if the assembly process was broken down into small steps, anybody could do it. And so they hired anybody, and they were really small not remedial, but really small steps that really anybody could do. It was dangerous. They didn't really have safety practices because this is all kind of brand new. So in 1911, this kind of started in 1908, but in 1911, 200 fingers were severed in that year alone. So it's just a little tidbit for you. But the workforce was happy because he more than doubled the daily wage of $2.25 per day to $5 per day. So they figured, who needs 10 fingers, right? They made so many, about 8,000 per day, that the cost of them was down to $300. So even the workers, working for a couple years after paying expenses and living expenses, could afford their own, which was pretty remarkable. Henry Ford was also responsible for the first death by a robot. So he was the first Terminator, and it was when a worker was hit in the head by a robotic arm. So anyway, that was also, it's not Henry Ford, it was Ford Motor, and that happened in 1979. So that was much, much, much later. So if you're interested in other Model T facts, you can check out this presentation on the bottom of the notes. It was 20 horsepower, it went about 45 miles per hour. And interestingly enough, it got about 13 to 21 miles per gallon, which is pretty much how modern trucks of today are. So let's continue on into the early 1900s. Is Kishiro Toyoda. He introduced lean manufacturing and just-in-time manufacturing. So just-in-time manufacturing, which we're going to get to, you'll see a slide that says those words on here, means that all the parts arrive just when you need them. So you don't need to have warehouses full of stuff. If you're going to build a toilet, then you don't have a warehouse full of little flushing handles. A truck delivers them all the day that you're building them. So if you're going to manufacture 2,000 toilets, or 200 toilets in a day, then the truck comes that morning with 200 levers. If you're doing 200 toilets, and you just use them all up. That's just-in-time manufacturing. He also introduced the idea of Kaizen, and Kaizen just means good change. It's the idea of continuous improvement. We're always looking at what can we improve, how can we innovate, how can we make things better and better. And that, again, is a lot about lean manufacturing, and we're going to look at lean manufacturing here in a bit. In the mid-1900s, Jervis B. Webb Company creates the first coordinated conveyor system, and they continue to work in conveyor systems even today and offer a lot of variety. So you're going to get to work with a lot of conveyor systems with Vex Robotics, or you already have probably. Now, today we have these three systems. You're going to hear about these a lot. You've already heard about them maybe a little bit, but first is Automatic Storage and Retrieval System, ASRS. And with these, it's just something that moves material back and forth and transfers. So think of like an automated library of some kind where you have a computer that's going and it picks up the book and then it delivers it to the person. Then you check it in, it reads the barcode, and it knows exactly where that book needs to go. So you have an automated library system. These exist. Same thing with data, where you have an automated data system that goes and grabs the data file. Maybe it's a bank of CDs, or maybe it's a hard drive bank for large companies that are doing data storage and retrieval. Next is automated guided vehicles. These are vehicles that just run by maybe following some trigger. We are going to make some automated guided vehicles, or actually some of you probably did in the last unit, that follow lines. The line followers are automated guided vehicles. They're automated, but they have to be guided using some type of technique. So this says computer controlled systems using pallets to transport work to numerical control machine tools and other equipment, but they can be used to transport pretty much anything. And AI is artificial intelligence. That's where machines learn from experience. If it does something and it gets an error, then maybe it gives itself feedback, provides feedback and says, don't do that again, reset the limit so it doesn't move that far and hit something, whatever it is. That's AI. Manufacturing today is generally referred to now as computer integrated manufacturing. That is the name of this class. It's SIM. And in most manufacturing companies, you have a company-wide management philosophy for planning, integration, and implementation of automation. And this is called the Manufacturing Enterprise Wheel. We're going to talk about this in an upcoming presentation that is pretty quick. There's one main idea, and that's at the very center of this wheel. If you are full screen watching this, you can read it now. And that is the most important piece. It really started in the 1980s, so 30 years ago in the history of kind of how things have been manufactured, really not that long ago. So back to the word Kaizen, it means improvement, and it is based on continuous improvement by all pieces, from cleanup crews to the head executives. That everyone is looking at how can we improve, how can we make our job more efficient, make it better. That is Kaizen. And a flexible manufacturing system is something that adapts to a changing need. If you want to manufacture more than one type of item, let's say you're manufacturing toys for McDonald's play sets, and they're maybe little plastic cars, but they're different colors. So maybe to manufacture these, if robots are attaching wheels, robotic arms are attaching wheels to this, and maybe there's different size wheels or there's different colors, then flexible manufacturing code would load into the robot and would say, okay, now that we've manufactured 100 with small wheels, now we're going to pick up wheels from another bin that are a little larger and manufacture it and apply those wheels. Or maybe it's sprayed with some type of paint, although they don't really do that with McDonald's toys because kids eat them and get sick and die. We don't want that, so they're now usually molded solid color plastic. But let's say you have an item that needs to be painted. Maybe you need 3,000 of them that are red, so they're painted red, and then the code is counting. Once 3,000 hits, we have a different color that we spray them with. So that is flexible manufacturing, and it can increase productivity by a lot. This is up to 50%, because you don't have to stop the line. A person doesn't have to be involved. It's just counting units where it makes its change. Just-in-time manufacturing, we've talked about this. Objects arrive just when they're needed. Toyota production system this applies to automotive manufacturing. It began in the 1980s to make manufacturing more productive, and the idea is this employs a lean production strategy. So all of these things, which is really largely what lean manufacturing is. We don't really need to talk too much about TPS per se, but lean manufacturing is just a systematic elimination of waste. How can we get rid of the things we don't need and make everything a lot more efficient and productive? And let me look at your questions here. So far we're looking pretty good. So again, I think we just covered the core philosophy of lean manufacturing. That's kind of right in here. And the last thing that we're going to take a look at is Six Sigma. Six Sigma indicates measures of quality for near perfection. If you produce fewer than 3.4 defects per 1 million opportunities, you have reached Six Sigma. And the sigma is a standard deviation. So 6 standard deviations from average. And you can talk with some of your math teachers about, oh, what's standard deviation mean, Mr. or Mrs. Math? And they'll probably tell you what it means, and that can be a great discussion about how that applies to Six Sigma. So 6 standard deviations back is 3.4 defects per million. And in order to reach that, you really have to identify and correct what's causing the defects. So you're always looking at trying to improve, continuous improvement. You really have to look again at what's causing this to do it. That is the goal of most manufacturing, is to reach Six Sigma. So you may hear, how can we reach Six Sigma? Somewhere in your life, someone is going to be talking about that. Almost guarantee it. And finally, we look at manufacturing of today is using rapid prototyping. We have some of them. And the ones that we have are fused deposition modeling. It's using plastic and putting plastic down. 3D printing that's what we call them. Selective laser sintering and stereolithography. We're going to look at videos of how those work later on. A work cell is a group of manufacturing pieces all connected together. And in our milling room, we have the mill and we have a robotic arm. We may also include a sander. That would be a work cell where everything is kind of all next to each other, where they can be working sort of together, even with a human moving them side to side, or with a robot. And finally, a work envelope is just the range of motion of a robot. Robots can't go forever. They can't get up and walk, or well, some can. But for manufacturing, our milling machine has a work envelope. It can only go so far in the X direction, and the Y direction, and the Z direction. And that's its work envelope, the entire range of motion. The robotic arm that we have in the milling room is the same thing. It has a range of motion. How far can it reach? Where can it place objects? It can't continue to move back forever, just like my arm can't, because it kinks on itself. So there is a work envelope, and that bell signifies we are done.